Welcome to the overview of the SHOT report and assignment. I just thought I'd go over where these documents are found and a few highlights of recommendations and key figures from the Serious Hazards of Transfusion report from the UK. So here's the website up on the screen. You can find this up here at shotuk.org. And why am I talking about cases from the UK? Well, here's this other tab is actually the system from the Government of Canada. So in Canada, we also have a reporting system. So a couple different things here, a transfusion error surveillance system and the transfusion transmitted injuries surveillance system. And as you can see, these reports are quite old compared to where we are now. So they've done a summary from 2009 to 2013. So part of the reason I like to use the SHOT UK is because they're up to date. So they will give an overview of each year, and the latest posted ones are the summaries from 2018. So it's only a year behind. So that's why I like to use the SHOT UK. Just so you know, there is this system in Canada and as you saw in some of the transfusion reaction procedures that you just did those flowcharts on, there is a system for reporting adverse events, especially serious ones like trolley and taco and different infections and things. So Canada does have its own system, but the reporting is much better in the UK, so they're a little easier for us to look at. So here I'm in the resources section of their website. This is good for us because we have here the cases. So this is every adverse event in 2018 that was reported in the UK in a simple little one-page summary for each case. It's really short, but there are a lot of cases. The other one I'm going to look at, just a few things today, is the figures from the annual SHOT report. It's talking about statistics and all kinds of things they can measure and track. If you're interested, there is this definitions and SHOT categories here. They use a lot of acronyms that we'll see, and so if you get lost in any of those, have a look at these definitions and it tells you about what all those acronyms mean. Every year they also put out these recommendations, key messages, and learning points. The whole point of having this system for reporting adverse events is to try and prevent them. That's the whole goal here. So by countries tracking these events, every adverse reaction, and then trying to learn from the situations enables, hopefully in the future, less reactions to happen. So let's have a quick look at some of the figures from this annual SHOT report. Just wanted to highlight a few pages. So as you can see, they're free to share. SHOT shares this material, but this is their material. I haven't added anything to it. And I'm just going to scroll through a couple pages here. So page 4, and I'm going to skip a whole bunch of things. Just wanted to highlight a few things so you get an idea of what's in this report. Okay, so the number of reports submitted to SHOT and per 10,000 components issued 2010 to 2018. So 2018, the total number of reports of any adverse event, including near misses, they're tracking those as well, is 4,037 reports. Now, why do you can see this blue line, the trend? Why is the trend increasing? That's actually a good thing, because if an event isn't reported, you can't learn anything from it. So this increase in reports is a great trend. On to page 8 here. And you can obviously go through and scroll through this on your own. I just wanted to give you a few highlights. So page 8, so what were the errors in 2018? So errors account for the majority of the reports. So 87.3%. The green section, not preventable. So some patients do have a reaction and you can't prevent that. Possibly preventable, preventable, another 4.4%. So imagine if we could prevent all those errors from happening. Think about how many reactions would be prevented. That's a little astounding to think about that. I'm going to jump down to page 11 here I wanted. Let's go back up one. A summary of the data for all the different categories. So what they do with all of these reports is they do categorize them into different groups. So the very top one here, near misses. So near misses, 1461. So out of that 4,000 or 3,000, oh, they're tracking 3,300 here. 1461 were near misses. So that's, good in a way that they weren't causing incompatible transfusions. But those are really good learning opportunities there. What are the main ones here? I want you to see IBCT, incorrect blood component transfused. 272 of those. The other big one that matters for us serologically is this hemolytic transfusion reactions. 35 of those out of 3,300. Okay, then some of these other ones we can obviously not prevent. So we've got trolley, transfusion-associated dyspnea, and et cetera, et cetera. They have their own categories like RBRP, right blood, right patient. So the right blood did go to the right patient, but there was an adverse event associated with it. So just giving you an idea there. Down to page 14. How many actual ABO incompatible red cell transfusions took place? So from 2016 to 2018, this happened 8 times over 3 years. Okay, so it doesn't sound like a whole lot, but that's good. But this is called basically a never event. This should never happen, and it happened 8 times in 3 years. So that's one of the huge goals with these, is to get to the place where that does not happen anymore. Compared to like an iceberg, 907 near miss events. So those were prevented transfusions, which is good. All right, then I wanted to go down to 26. So out of the cases that did happen, they've got clinical ABO incompatible red cell transfusions, 3. And I believe this is over that same period. Sorry for the scrolling. What they do is categorize some of these into clinical versus lab. So this page is clinical, which means the error happened on the clinical care staff side. So here, this case 8.1 was an administration error. Case 8.4, and you'll see these in the case summaries that you'll read after, was also an administration error. Case 8.5 was both a collection and an administration error. And all 3 of these cases caused an incompatible red cell transfusion. And you'll notice in case 8.1 that there was a major morbidity. So either that patient did die or nearly did. Then the next page says, well, what about the lab side? Because errors happen on both the lab side and the clinical side. So case 8.2, it was a testing and an interpretation error, causing also a major morbidity. So you can see how this is a never event. We never want this to happen, but it did. The other errors were related to a transfusion of fresh frozen plasma, cryoprecipitate, and FFP. So interesting to see them categorized by lab and clinical. I guess I could have scrolled down to this one. So looking over the long term, I like this page. The number of ABO incompatible red cell transfusions from 1996 to 2018. So that's how long they've been tracking this data. This is actually really good. To see this decrease statistically, that is fabulous. And that's what we want to see more of, right? Let's get to the point where this never happens. So we're going to take these stats from the UK kind of to represent the kind of developed world as a whole. It might not be exactly the same statistics, but it should be very similar for any developed country. One thing I wanted to share is this term called hemovigilance, because I saw this slide and went, yeah, this is what hemovigilance does. This is a term that just describes this whole process of reporting, tracking, statistically measuring all of these adverse events that have to do with transfusion. It's creating the structure and the system to be able to correct procedures, to prevent errors by putting in place the steps and the checks and the balances to prevent errors. And so this hemovigilance term applies to this whole system to enable prevention of errors. So I just wanted you to hear that word, hemovigilance. All right, couple more interesting things. Going to hop down to page 47. And I thought this was a good, actually I think I wanted 46. Yep, that's okay. Location of major hemorrhage incidents in the ER. The theater just means the OR. So usually you're having major hemorrhage protocols in the emergency room and the OR. Just to let you know, you don't have that context yet. And what they've done is, they're tracking all kinds of errors to do with any transfusion, which includes massive transfusion protocols or major hemorrhage protocols is what these guys call it. So where are the holdups? So they're saying what some of the main problems with massive hemorrhage protocols is that there are delays in certain places. So they're even tracking those. And if we start at the very top here in the big box, 30 cases here had to do with communication. Failure to keep lab staff updated, failure of lab staff to understand the urgency, failure to follow advice from clinical staff, failure to provide location of patient, miscommunication between clinicians. Okay, lots of communication needs to happen with the massive hemorrhage protocol. So I just wanted you to see all the pieces in the puzzle as an example of knowing your role, knowing how the procedures affect what you do, and how you, going into work in TM, if you have a good knowledge of the procedures and you know how an MTP should work, then you'll be able to do your part the most efficiently. Just wanted to highlight that. Down to page 55. Now they did categorize which section makes the most errors, clinical and lab, and it's about, it depends on the year, but it's about half and half, sometimes a third lab, 2/3 clinical. It also depends on who does what in what hospital. So I think in the UK, the nurses do collect a lot of samples in some places, so that could affect the data as well. So I just wanted to show you this page. This is about lab-specific processes and steps, and showing at which stage the transfusion process the primary error occurred. So we've got errors occurring at sample receipt and registration, testing errors, component selection, component labeling, HSE is handling and storage, and then miscellaneous. So just to have an idea that, yeah, these errors do happen in the lab. Okay, everybody has to be responsible as part of the team, and you know this. So this reporting and this hemovigilance is not a blame game. It's just about learning how to function the best as a team for the best patient care. So just wanted you to have that idea. So the last few pages I wanted to just highlight here, I thought were some interesting stats. Let's go back up one. clinical symptoms associated with a delayed hemolytic transfusion reaction. I thought these slides were good because we've just been talking about that. So in tracking the symptoms of patient symptoms for delayed hemolytic transfusion reaction, the two big ones are dark urine, and we're talking like in your procedures is talking about red or brown. So both of those can indicate hemolysis. So we've got dark urine and fever. Those are the big symptoms. Plus, it's possible to have chest pain, chills, dyspnea, and possibly rigor. So those are clinical symptoms, and I hope that connects with why we look for those things in a transfusion reaction investigation, right? Fever is important. A change in that immediate onset of dark urine is important. So two other slides related to this delayed hemolytic transfusion reaction. What did they actually test for in the UK? Hemoglobin was a big one, bilirubin, DAP positive, and something else they use is an LDH and spherocytes. Okay, so some of these we've talked about. I think in Canada, or at least in BC, we don't do LDH super commonly anymore, but it is possible. So that's lab indications, which goes right along with what we were talking about in Lab 8. And then the last one I wanted to show you was, what antibodies were actually implicated? Does this go along with what we've been learning? So antibodies implicated, the top culprit was anti-JKA. 10 of those took place. Okay, and then for a mixture including JKA or JKB is 4 of those. And you've also got a Duffy A, an M, which is interesting, a little C, or a mixture. And remember, it might depend on the year which antibodies actually come up, because this would be happening in different patients. But cool that, kind of cool that the KID system, which we've been learning about, actually is true. So that was just a few figures from the SHOT report. And then I wanted to show you what you will be reading. So this will be posted on Moodle, and this is the part I would like you to read through. Make sure to look at the reading list. You do not need to read this whole thing. This is 175 pages, and I've cut out about a third of that, I think. And as you can see, the writing's really large, so the pages are not long at all. So I'm expecting this to take you about an hour to go through the reading list. So cases from the 2018 report. So I'm just going to scroll through the first couple here. There is a title page, so you can find the page numbers for all those categories. I've listed the categories I want you to read along with the page numbers or the slide numbers. So please do have a look at that. And I'm going to go down to, let's see if it'll take us down to number 8. This is one of the sections I want you to read, is human factors. So what actually happened? So here's a case on a page, sometimes continued on a second page, but that's about it. So the first case, culpability attributed solely to a staff member, but system problems also identified. So it tells you kind of what the case was, what happened, and then what was learned in the end. Okay, so that's part of the reading I want you to do. And then there's another section. So I've taken out the NTD section for you to read, but here's an example of a case. So that was one error, and the next one's a new case. So you can see this shouldn't take you too long to read through those SHOT cases. And then I've posted the assignment as basically a reflection, but in a forum on Moodle so that you can all see what each other is posting. So do be aware that what you're posting, everybody can read. So here's what's posted on Moodle. There's the reading list, so just the chosen pages for you to read. Don't read the whole thing. And then the assignment. So I want you to read through these thinking about this assignment. So choose 3 cases from this report. So that's 3 individual cases, okay? Not a whole category, just 3 cases. And then tell us about those 3 cases. So give us the page number. Explain the adverse reaction or the outcome of that case. Why did this case stand out to you? Why did you pick it? And then, could this adverse event have been prevented? And if so, how? Talk about that. So those will be 5 marks each for 3 cases. And then I'd like you to give me a bit of a journal reflection in there as well. So explain the impact this report has had on you, including one big idea that you will take with you into your practice as a tech. So this is an affective domain learning, right? What are the attitudes that you're going to take with you into your work? So that'll be worth 5 marks as well. So this assignment will be worth a total of 20 marks. And I've made it due on Sunday night, this next weekend. And I hope that's enough time. Like I said, I hope this whole thing will take you about 2 hours. A few minutes to watch this presentation, about an hour, I think, to read these cases, and then a half hour to come up with your post. So that's the summary of the SHOT report, the Serious Hazards of Transfusion. And I do hope that reading these cases does make it quite real. I had a student ask me last year, were these real or are these just made up? No, these are real cases that happen to real people each time. So we're going to keep that in mind, and hopefully that sticks with you as you go out there. So that's this presentation, and hope you enjoy reading the SHOT report.